Hi, I'm Beth Dickey of the NASA Headquarters Office of Communications. Welcome to The Leading Edge, where we take an in-depth look at aeronautics problems that NASA is working to solve through its own research initiatives or in collaboration with others. Today's topic is green aviation. In just a few minutes, we'll take a closer look at how NASA's efforts to make air travel cleaner, quieter, and more economical are going through new aircraft designs and innovative ways of operating. But first, we have a few words from NASA's administrator, Charlie Bolden.
In business and in our personal lives, the aviation industry is a key enabler to our way of life and the smooth functioning of our economy. But with today's procedures and equipment, the air transport system is near maximum capacity. Future growth also could be limited by rising concerns about the environmental and noise impacts of aviation. To address these challenges, NASA's Aeronautics Research Mission Directorate is looking for new ideas, conducting basic research into new technologies and operational procedures, and trying out new vehicle operations and safety technologies in relevant environments. Through our research, we hope to expand capacity, enable fuel-efficient flight planning, and reduce the overall environmental footprint of airplanes today. In the future, we want to reduce delays on the ground and in the sky, and improve the ability to operate in all weather conditions without compromising safety. This is an exciting time for NASA Aeronautics. NASA's new focus on innovation means a renewed focus on aeronautics research to help overhaul our air transportation system and create safer, greener, more effective travel for everyone. This year, NASA is starting its first new aeronautics initiative in a decade, a program of integrated systems research focused on developing technologies to reduce the impact of airplanes on the environment. President Obama's proposed budget for NASA in 2011 and beyond includes even more money for green aviation research, next-gen or next-generation air transport system air traffic management research, and preparing the nation's airspace to accommodate unmanned aircraft systems. Aeronautics research by NASA and its predecessor, the National Advisory Committee for Aeronautics, has been one of the most important contributors to America's economy and quality of life in the past 100 years, and it will continue the tradition in the future. At NASA, we've always pioneered cutting-edge aviation technology, and will continue to develop the technologies that will help the flying public every day. They may not even think about NASA as they take off in an airplane, but we'll be right there with them, looking at the key challenges to validate flight-critical systems and increasing the efficiency of air traffic management. We're talking about real technology here, but again, it all boils down to people, on the ground and in the air, and making an essential part of daily life better.
As Administrator Bolden indicated, the President's budget request for fiscal 2011 includes funding for a new program of integrated systems research. We asked the acting director of that program, Jean Wolfe, to tell us about it, and this is what she had to say.
Green aviation and environmentally responsible aviation are just buzzwords or catchphrases for a cleaner, quieter, more fuel-efficient aviation system than we have today. The energy and the environment are currently a challenge facing us as a nation. If you live near an airport today, the smog levels partly are a result of the air traffic coming in and out of the airport. Also, airplanes themselves are very noisy, and people don't want to live close to airports for that reason. NASA is doing research in both the aircraft or vehicle side of the aviation system, as well as the operations side, or how the aircraft operates in the national airspace system. On the vehicle side, we are doing research and development into airframe technologies, lighter weight, composite, non-metallic material structures to make the airplanes lighter and therefore burn less fuel. We've been operating on what we refer to as a tube and wing type concept for many years now, and we're looking into novel architectures. We have done preliminary research and flight testing on a hybrid wing body type aircraft, which basically looks like a flying wing. We're also doing research in how the aircraft operate in the National Airspace System. We're looking into ways to be able to allow aircraft to make a continuous ascent and descent in and out of airports, as opposed to the stepped approach that they're currently doing, and that way will allow them to burn less fuel. NASA conducts its research through 4 of the 10 field centers: the Ames Research Center and the Dryden Flight Research Center in California, the Glenn Research Center in Cleveland, Ohio, and the Langley Research Center in Hampton, Virginia. In addition, we partner with other government agencies, such as the Department of Defense and specifically the Air Force, as well as the FAA, the Federal Aviation Administration. In addition to that, we partner with universities and the aviation industry to bring the best talent to the research. NASA Aeronautics is currently set up in a 3-tiered approach to doing the research and development. We start out at the innovative and high-risk concept stage, where we've got some seedling funds that we apply to these innovative concepts and ideas. We then conduct research at the fundamental or basic research level in our fundamental research programs, and we then take the concepts and technologies that have been developed there and conduct further research on those technologies at an integrated systems level in a real-world or relevant environment. You can see a lot of technologies that were developed by NASA on current airplanes that fly in the system today. I would say that we will see the results of the research and development that we're currently undertaking will enter into service in likely the next 10 to 20 years or beyond. I would envision a future aviation system is one in which people want to live close to an airport because it makes it easier for travel for them. A future system would be one in which someone like me who lives very close to the Dulles Airport in Virginia can have a family barbecue outside and not have our conversations interrupted by air travel overhead.
So let's delve deeper into our discussion of green aviation. With me now is Carl Burleson of the Federal Aviation Administration's Office of Environment and Policy. Mr. Burleson, in that position, you oversee offices that develop policy and set goals related to environment and energy. They also do aviation forecasts, and they analyze the impact of the environment on the aviation industry, right? All right, tell us, do you think significant reductions are even possible in environmental impact now?
Well, first, Beth, thanks for the opportunity to join this conversation with NASA. But to that question, absolutely. In fact, not only are they possible, it's going to have to be necessary. As we've gone and looked at an analysis of what is going to be required for the next-gen system, it's very clear that if we're going to get the full capability of next-gen, we're going to have to reduce the noise, air quality, and climate impacts. And again, I think what's also become very clear to us is we're going to need a wide variety of solution sets. We're going to be able to have innovation in the vehicle, innovation in how we manage the air traffic system, and innovation in alternative fuels.
Well, let's start with the vehicle category. What do you see happening there?
Well, I'm very encouraged by the kind of research that we see happening. Certainly, what Jeannie was talking about in terms of the NASA efforts are really important. We see coming in the next few years, certainly in the 10 to 20 year time frame, that kind of 50% improvement in fuel burn. And this is absolutely essential because, again, if you don't burn the fuel, you don't create the emissions. On the NOx side, again, we see something similar in terms of a 60% gain. In a noise, if we're really radically successful, and again, this is going to be dependent because with NASA's help, is can we really bring that noise footprint down? from today's aircraft to about 1/6 of what we have in the commercial fleet today, so that we bring noise inside the airport boundary.
Well, let's see if we can drill in a little bit on the technology gains in airframes and engines on the vehicle side. I think we have a graphic that shows us some of the vehicle improvements that might be possible, or the environmental impact. There we go. Talk a little bit more about the advances in technology that we see.
Right, so you can see in this graphic, again, just the kind of numbers I was just walking through. But, and again, I think on the fuel burn, this is going to be a combination, I think, of the research that's coming out, both in the airframe itself, the composites material, how do you make it lighter, as well as the efficiency in the combustors. I think those together are going to be able to get us these kinds of fuel burn improvements. On the NOx, again, this is a real challenge because, as certainly the folks in NASA know, the physics of combustion with the kind of technology we have, you tend to have more NOx produced when you have these combustors that produce less noise and more fuel efficiency. But again, I think the challenges are there, and I think they can be met. And then finally, I think the noise, again, it tends to be the number one issue that we grapple with as a regulator. And I'm really hopeful that we're going to be able to address not just engine noise, but a lot of the airframe itself, because especially we've been successful in the last couple decades, so that now, for instance, in landing, a lot more of the aircraft noise is produced by the frame and the landing gear itself rather than the engines.
And I think we have a couple of illustrations. There's one that will help us show everyone what might be possible in noise reduction at or around an airport.
Yeah, you can see, I mean, again, you look at the left-hand side, this is the kind of footprint we're dealing with, and the hope is we can actually get to the right-hand side with a much smaller footprint, because it's absolutely essential, I think, from a regulatory standpoint, of how do we bring that noise inside the airport itself, so that, as was described earlier, so that families that are in communities around there can have that barbecue in the summer and have conversations without being interrupted.
And we've got one that moves for you that'll help you see the transition from a wide noise footprint, there we go, to a smaller one.
Right, well, you can see there the kind of footprint in today's commercial aircraft, and if you go to the next one, and the kind of shrinkage that we're hoping for. And again, and I think this photo is really good, because lots of times when folks are doing abstracts of airports, I've seen this in the next-gen posters, they don't tend to look at all those residences around. When you look at where major airports are in the United States, 40 of our top 50 airports are in major urban areas. So again, we're dealing with a fact that you have communities that are a key part of a stakeholder, and they're surrounding these airports, and we need to find ways of helping them deal with what is a really important issue in terms of national transportation.
All right, let's move on to the second category, air traffic management. What do you see happening there?
Air traffic management, I think, is going to offer a lot of the near-term gains. Certainly in the next-gen air transportation system plan, we're trying to find ways of building into every phase of flight gains in energy and environmental improvement. You can see in the chart here the kinds of potential savings. Some work has been done in looking at some of our top airports and looking at kinds of innovations. We're convinced that whether you're looking at ground operations, where we've done one study where, in essence, airlines are taxiing over 220 million minutes a year. That translates in an awful lot of fuel burn, so the degree that we can optimize that, we're helping. We're already working on using what's called required navigation performance departures from a place like Atlanta, which is saving $25 million a year for Delta Airlines. We're looking at how do you maximize the en-route structure in terms of more flexible and direct routing. And certainly, I think was mentioned earlier, we've done work in how do you develop continuous descent arrivals. NASA was a big part of the effort we put together at Louisville to pioneer this, and we're beginning to see that being put in the system today.
All right, and you mentioned a third category, low NOx, alternative
fuels. Again, I think as we've looked at the kind of challenges we face in terms of noise, air quality, and climate, it's become pretty clear that we're going to need multiple solution sets. And I think as we've looked at alternative fuels, we've had a combination of things come together that has really helped us. The energy prices have just soared in recent years. In fact, for the first time in 3.5 decades, the operating cost for U.S. airlines, fuel is the #1 operating cost rather than labor. that has really driven an interest in trying to find better supplies. Certainly on the climate side, we're trying to find alternatives to today's Jet A and find ways of producing lower carbon fuel. So we've put together what's called the Commercial Aviation Alternative Fuel Initiative, where we brought together the government agencies, airlines, manufacturers, and airports to come together to see if we can find these kinds of alternative fuels that will reduce the carbon footprint as well as improve air quality.
Now, for the past several years, NASA and FAA and a number of other government agencies have been involved in an air traffic modernization effort called the Next Generation Air Transportation System, or NextGen. What are the environmental goals associated with that?
Well, at the heart of our NextGen plan is we want to reduce the energy and environment footprint so as to allow sustainable aviation growth. And more concretely, we've set out goals where we want to reduce the absolute aircraft noise, even while you increase activity. We want to reduce the significant air quality impacts. Again, as I mentioned earlier, our airports tend to be in urban areas where there oftentimes are clean air issues. So every time you're trying to expand an airport, you run into problems. So we want to make aviation much less of a contributor. And then finally, we want to have what we call carbon neutral growth. We want the aviation system in 2020 to be producing no more carbon than it did in 2005. So these are all really challenging goals, but again, we think it's important to aim high. And as the audience can see in this chart here on the carbon emissions, again, we're not going to get there with any one solution. We have no silver bullet. The issue is, how do we put together a portfolio of solutions? And you can see here, air traffic management is that relatively thin slice, but again, it's more immediate of how we can change the system. The technology piece that is so vital that NASA plays that role in the airframe and the engine, that's what we're counting on for a large slice of how we get there. And then finally, alternative fuels is this new solution set, which again, I think in the longer term is really going to help us.
And you really think these goals are achievable?
Not only do I think they're achievable, I think they have to be achieved. And again, I think it's going to take some real innovation and collaboration among FAA and NASA and industry to get there. But again, as I said earlier, we are not going to get to recognize or realize the full capacity of what we want in the next-gen system and the benefits to Americans and air mobility unless we are able to tackle and produce this technology innovation.
Well, can we go into a little more depth about what is required to achieve these? These are very significant goals. You mentioned collaboration. Perhaps you can talk a little bit more about that and some of the aircraft technology that will be necessary.
Yeah, so I think one of the things that we've come to the conclusion is we need to find ways of accelerating the pace of technology change in U.S. fleets. And so one of the things that my administrator, FAA Administrator Randy Babbitt, just announced yesterday was the award of 5 contracts under what we call the CLEAN program, the Continuous Lower Energy Emissions and Noise Initiative. And under that program, the FAA is putting up $125 million over 5 years to work with the industry to accelerate and mature technologies to get them into the fleet faster. The nice thing about this program is it's a matching program. So for every dollar of taxpayer money, the industry is matching it or exceeding it. And so again, we're really focused on how do we get these technologies sooner. Now, an important part of that is we're really working closely with NASA and the ERA program to try to create this conveyor belt of, again, NASA developing the concepts and bringing them to a certain level and then trying to bring them into an accelerated certification process through CLEAN. So I think that's the kind of partnership and innovation we're going to need to meet the kind of technology goals to get the environmental protection we want.
And I think one thing that you believe is very important is getting fuels to a drop-in stage.
Right. Again, I think we looked at this question several years ago, and it became very evident that the idea of going immediately to a hydrogen base or some real configuration of the fleet was not going to work, because when you think about it, there's hundreds of billions of dollars of embedded capital in today's, at least in U.S. 22,000 aircraft. So we came quickly to the conclusion that we were going to have to find an alternative that would drop in using today's aircraft, today's engines. So we've been working over the past couple of years to develop the qualification or the certification of this. We've been able to get the first new fuel approved in late 2009. We're hoping to get a 50% biofuel approved either late this year or early next. And again, I think NASA plays a very important role in this because part of the effort is not just in the safety, which FAA is concerned with, but it's also the chemical, what actually comes out of these alternative fuels, what are the emissions, making sure that we really are improving the environmental footprint.
All right. It sounds like a huge challenge, not only for us in government, but for the industry that we have to work with as well. Talk about some of those challenges for industry and a little bit about what FAA and industry need NASA to do for them.
I think my simple answer really is I need NASA to continue to do what it has done traditionally, and I think industry does too. When we look back at the environmental improvements in the United States system over the last few decades, probably 90% of the improvements in noise and fuel burn and emissions has all come from the technology we have in the aircraft and engines. And again, that relates back to the innovative research that NASA has done over the decades and work with industry and FAA to bring that out. So again, I think fundamentally we need NASA to continue that role. And if anything, I think what we really need is NASA to accelerate that. Some of the, the shorthand, the N+2, the N+3 technologies, we need to actually move those forward. We need to find ways of getting that technology to a certifiable level sooner.
And N+2 is vision of an aircraft that could enter service around 2025, N+3 around 2035, and there's actually one that you're quite enamored with.
Well, I mean, I think we've been, I was up getting a briefing at MIT several weeks ago, and I was encouraged by the fact that there's some innovative thinking on not just kind of going to these radical new configurations, but even kind of modifying today's tube and wing into a double bubble. And it seemed, at least in the initial research, that we were going to be able to get significant gains in noise reduction and fuel efficiency. And that's the kind of thing.
And we've got a picture of that double bubble. It's the airplane in the cloud. There we go.
Yeah. So again, you can see in this kind of aircraft, you're not going to a radically different sort of a delta wing configuration. This is much closer to the configuration we have today. And I think that's not unimportant when you think about it's not just the aircraft that you have to worry about, but it's the infrastructure that supports it. So bringing that kind of aircraft in today's airport infrastructure is a much simpler equation, I think, than the delta wing. But again, I think this is the kind of thinking and innovation we need. And so I think that's really important if we have these kind of concepts and the research and the support with industry to bring these kinds of things forward sooner. Now, another area that I think it's going to be really important for NASA, for us, certainly is in the science side. Because as I look forward and look at some of the challenges we face, climate is really, I think, going to be the thing that most potentially constrains air travel. So certainly CO2 is CO2 regardless of altitude, but all the other emissions have different altitude effects. And certainly we need a much better understanding of what those impacts are so as to better design the solution set. So again, I think NASA plays a very important role there.
Great. Well, Carl, thanks for being with us to share your thoughts today. We're going to take a quick break. When we come back, we'll continue our discussion with NASA's Fay Collier about environmentally responsible aviation. But for now, we want you to get a chance to get acquainted with one of our aeronautics research centers, the Glenn Research Center in Cleveland, Ohio.
The NASA Glenn Research Center in Cleveland, Ohio, lifts people to new heights with our technological advances in aeronautics. Programs that inspire our next generation of innovators and explorers, and discoveries and technologies that will one day help us travel to new destinations. Our partnerships with universities and industry help create technological improvements, making U.S. aeronautics products more competitive in a global market. In fact, you'll find technology that we've helped develop on board just about every aircraft today, making air travel cleaner, quieter, safer, faster, and more energy efficient, all while helping to protect our environment. Known for our expert capabilities in aircraft icing research, we develop, test, and certify methods to diagnose and mitigate ice buildup on aircraft. Results from this research also help train pilots to successfully handle potentially hazardous in-flight weather conditions. Our innovations in propulsion, materials, and structures improve the durability and environmental quality of aircraft engines. In addition, our advancement in sensors, electronics, and control technologies are making engines safe and intelligent by identifying anomalies before they become critical problems. As part of our mission, we also strive to lift our nation's students to new heights, inspiring them to be the next generation of innovators and explorers. Our partnerships with teachers and schools help increase American competitiveness in science, technology, engineering, and mathematics. NASA Glenn will keep lifting people to new heights as we continue to make discoveries and develop innovative technologies that will help us explore new destinations.
You're watching The Leading Edge, an aeronautics research discussion program brought to you by NASA. Let me introduce our Associate Administrator for Aeronautics Research, Jaewon Shin, and Fay Collier, Manager of NASA's Environmentally Responsible Aviation Project. Dr. Collier led the formulation of the new project. Dr. Shin and Dr. Collier will continue our discussion looking at NASA's role in green aviation research. Jaewon?
Great. Thanks, Beth. Once in a while, on rare occasion, I get to play David Letterman like this. So I think we're going to have fun talking about our exciting research activities, trying to help environmental protection. But Fay, thank you for being with us and sharing what you're doing in your project.
Glad to be here, Jay.
Yeah, I'm really looking forward to it. Carl Burleson certainly laid out and spelled out challenges that we're all facing in the community. So let's talk about what NASA Aeronautics is doing, particularly in your project, to address some of those challenges. And let's start talking about new aircraft configuration.
Okay, so first of all, Jay, thanks for having me here today. I really appreciate it. I'm here obviously representing the efforts of about 100 people out there working at the NASA centers, and very happy to be here to share what we're doing here. Carl mentioned tube and wing aircraft and near-term modifications to tube and wing. So we're looking at advanced tube and wing aircraft as a possible solution going forward. Working.
We have a graphic with some pictures of that.
Right.
Can we have the picture of all the airplanes, please?
Right.
There we go.
So in addition to advanced tube and wing, we have other configurations like high wing, truss-braced wing, strut-braced wings, engines mounted on top of the wing for noise shielding. So there are many different ideas that we're pursuing to work toward the environmental challenges that we talked about in the first segment.
Great. We are seeing fairly new configurations, but still some variation of tube and wing configuration that's currently flying.
Right.
What possible gains can we have out of this so-called matured configuration?
Well, as Carl indicated, and I'll reinforce, there still are significant gains that can be had in the near term on tube and wing aircraft. And we're working with FAA and other government agencies as well as the industry to try to explore some technology over the next 10 years or so that we think in the near term can make a difference and also set us up for farther term. To answer the question directly, we're talking fuel burn reductions on the order of 30 to 35% may be possible in the near term, with larger reductions possible in the longer term, giving ourselves a chance to mature the technology.
And they're showing us some views here of different
Right.
kinds of configurations.
So what we have
closer
here, yeah, thanks, Beth. What we have here is a tube and wing aircraft with an open rotor technology, and we'll talk a little bit more about open rotor in a few minutes. I think there's a couple of more of these that we can look at. Here's one I mentioned a little bit earlier. It's a strut-braced wing with the engines above the wing for additional noise shielding, and then a box wing. So we have folks looking at a box wing configuration in addition to some of these other ones that look a little bit like today's tube and wing designs.
I also see this model airplane here, hybrid wing body configuration, as we've been saying. What types of green technologies that you can envision out of this kind of configuration?
Well, this is this aircraft here. This model of this aircraft here is known as a hybrid wing body. This one is a little bit farther out than some of the other ones that we're looking at. So some of the features you'll see here, it's got embedded engines. It's again, the fuselage and the wings have been blended together. The bottom line on this type of a configuration, and it's a bit like the double bubble that Carl mentioned a little bit earlier, is it's got this wide body. We can take advantage of that for noise shielding, so that we can prevent the noise from reaching the ground that way. It's also very efficient. It has 25% more efficient planform, lower drag, which translates to smaller engines and less thrust. So that's what we like about these integrated configurations.
Good. Fay, we've been talking about, Carl also talked quite a bit about great challenges that we have to overcome. And you've been talking fairly challenging goals individually, but I understand the biggest challenge is to do this simultaneously. So simultaneously reducing fuel burns, emissions and noise.
Yeah.
So what is our approach, and let's talk about those key challenges, how difficult they are.
Yeah, okay. So first we'll remind everybody again what kind of goals we're talking about. Carl mentioned them earlier. They are significant. 50% reduction in fuel burn. Similar improvements in local air quality, so reducing NOx emissions. Fuel burn translates to carbon, so lower carbon output to the same level. And then the real crux of the matter is integrating all of that and then reducing noise simultaneously. So we're trying to get to 1/6 the noise profiles of today's aircraft. So those are the challenges with respect to, or those are the goals that we're trying to work toward. And there are some key challenges with respect to some of these configurations that we're pursuing, key technical challenges. The overriding one is this idea of integration. And then underneath that, we're going to need new aircraft structures, lighter weight, damage tolerant. We're going to need, in the case of a hybrid wing or a highly blended configuration, we're going to need advanced flight controls. And then we're going to need advanced engine technology, very efficient engines to integrate into these airframes to achieve these goals.
Let's get into a little more details in those technical areas. How about flight research to begin with?
Right. So over the last 4 or 5 years, we've been doing quite a bit of flight research into the flight control challenge that I mentioned. We've been doing that research on the X-48B out at NASA's Dryden Flight Research Center. And I believe we have a video. Gary Cosentino is our expert out there, and I think we have a short video of Gary and the work that he's been doing with the team out there at Dryden.
He's coming left to set up for the entry for 2-4.
Yeah, that was a short clip of the X-48 in flight, and now we're going to go to Gary.
For the Science and UAVs group, and that's within the Flight Operations Directorate at NASA Dryden. And NASA Dryden is all about flight research and flight testing. We have the facilities and the weather to test one-of-a-kind experimental vehicles, and flight operations are the folks that conduct those tests. The X-48B is the epitome of all the work that has been done in looking into the blended wing body concept. The blended wing body concept is a unique shape. I look at it as the middle ground between a conventional tube and wing aircraft and a pure flying wing. There has been a lot of analysis done, a lot of wind tunnel testing, and developing the flight control system to keep the airplane flying safely, given all of its unique characteristics, is really the challenge of the work. Our pilots report that it flies like any other conventional transport aircraft. We have, in the end of the research, gotten to explore those ragged boundaries, and we've found every time that the flight control system keeps us safe.
He's coming left to set up for the entry
For me, that what makes it the most fun and the most inspirational is this truly is a unique, one-of-a-kind and first-of-a-kind aircraft. We've had 80 safe and successful flights on a very high-risk, one-of-a-kind vehicle, and that is a real testament to the flight test discipline and the kind of knowledge that we have accumulated to fly an airplane like this safely. To have flown 80 successful flights is really a remarkable achievement.
So Fay, isn't that wonderful? I was actually in one of the flight following in the chasing airplane. It does fly like real airplane.
Yeah.
And
It's been a very exciting program, Jay, and as you know, we've finished phase 1, and now we're moving into a short 18-month phase 2 effort associated with that aircraft.
right, that's what I'd call a real cutting-edge research. How about talking about materials research?
Yeah, materials research is another key area that we need to keep our eye on and keep working really hard. We need the weight reduction from our materials and structures research. And today we're going to talk about one of the ideas that we're pursuing, and it's called Perseus. And I've got a sample of it here. And we're going to pass this around to the audience. But first of all, what is Perseus? It stands for pull-truded rod, stitch-deficient unitized structure.
Say it 3 times fast.
Oh, yeah, right.
I can never say that.
Yeah, I'll leave that up to you, saying it 3 times fast. But the neat thing about Perseus is it's resin-infused stitch composite. And it goes back probably 20 years in NASA, where Marvin Dow was one of the first pioneers in this area, and Don Jegley, who we'll talk with in just a few minutes via video, is the engineer pursuing it. But Perseus is lighter weight. It's damage tolerant because of its stitching. It prevents the propagation of cracks if they should arrive or arise in the structure. And we think in the long run, because of its low part count, in the long run it will be lower cost. So it's got a lot of very, very attractive benefits to it. And we really think that this could be the future of aircraft structure here. So we've got Don Jegley, who's prepared to talk a little bit more about Perseus. And in the meantime, I'm going to pass this around to the audience.
You want to build a clean, green airplane. The primary thing you want to do is make it lightweight from the structure side. This is the James H. Starnes Structures and Materials Laboratory. We've tested aircraft components in this building since the 1940s. We test trying to determine how a structure will perform in flight. What we try to do with the test specimen is we push it or pull it or twist it until we cause it to break. We want to get the best load carrying capability, the strongest structure for the least amount of weight. The biggest challenge for the structure side with the green airplane is getting to these complex, complicated shapes for the aircraft that we haven't looked at before. Perseus is designed so that even if you get a damage at one location, a very severe failure at one location, the cracks will only spread so far. If you look real close, you might be able to see that there's stitching along here. Those stitches go all the way through this side to this side, and that helps hold the layers of structure together. You've got layers of material that are built up, and then you have, that gives you your skin, and then you have part that wraps around here. So what you end up with is a rod in the center with wraps around it, and then you have a series of these lined up together. If you have a crack in a structure in flight, the crack will stop. The pilot will know there's that severe damage, and he'll be able to land the plane safely. Now we've got stitching, plus the protruded rods, plus all these other things that are coming together, and it's looking closer and closer to the point where we really will be able to apply this technology to a real airplane someday. And 10 or 15 years from now, I hope to be able to see that happen.
Good. I actually have an interesting story about Dawn. I was visiting Boeing R&D in Huntington Beach several weeks ago, and she happened to be there also having a meeting with our industry partners at Boeing. And she actually gave me a briefing of what we are working with Boeing, and Vice President of Boeing R&D at that point whispered in my ear, "Isn't this wonderful?"
Yes.
That NASA employee briefing to me at Boeing side.
Yeah.
So I think it's a good example of our close collaboration with industry partners. But let's go on, and certainly not the least, it's one of the major pieces of research need that we have to do. But let's talk about engine research.
Yeah, engine research. So we're doing engine research at the NASA Glenn Research Center in Ohio. And ERA has a two-pronged approach. UHB engines, ultra-high bypass ratio engine technology is one area where we're working. And the whole idea is to increase the propulsive efficiency and thereby reduce the fuel burn of these advanced engine technologies. So these engines are getting larger in diameter, and they have a couple of technical challenges that we're attacking associated with the larger diameter. The second piece of the strategy is taking the nacelle off the engine. We're looking again at open rotor technology, which is something NASA explored back in the 80s, and that's sort of coming around to being in a rebirth mode. So on the screen now we have a picture or a video of an open rotor type configuration. It has counter-rotating propellers, and that is the challenge. Those propellers cause a lot of noise, and so we're trying to develop approaches to reduce the noise of an open rotor configuration. So as I mentioned, we're doing that work at NASA's Glenn Research Center, and I think we have a short video to tell us a little bit more about what's going on there.
Hi, I'm Dale Van Zanny, NASA Open Rotor Technical Lead at Glenn Research Center in Cleveland, Ohio. I'm in the 8x6 high-speed wind tunnel test section. This test section is capable of airspeeds up to Mach 2. The open rotor propulsion system will be tested here in this test section in the next few months for its performance at cruise Mach number. Currently, the open rotor propulsion system is being tested in the low-speed test section of the wind tunnel, shown here in an image, for their performance at both takeoff and approach Mach numbers. This is an opportunity to be involved in the creation of a new aircraft propulsion system that has the potential for large reductions in fuel burn. While there are opportunities for advances in conventional jet engines, the open rotors are one concept that could be a game changer in the relative near term. Open rotors are specialized high-speed propellers, so an aircraft with an open rotor propulsion system would be able to fly nearly as fast as an aircraft with a conventional turbofan. That is not true of aircraft that use conventional propellers. Open rotors are very fuel efficient. The challenge is to make them quiet enough to meet current noise regulations while still maintaining their fuel efficiency. Open rotors were studied in the late 1980s and early 1990s, so their fuel efficiency is well established. With modern design methods, we can actually make very subtle changes to the shape of the blades, which make them quieter, but also maintain their fuel efficiency. So the testing that we've done so far has shown that we've made progress since the earlier designs in accomplishing that goal.
Hey, a lot of exciting work. And as you mentioned earlier, we have a lot of top-notch researchers and all other people working in this within NASA, but we cannot certainly do this alone. So let's talk a little bit about partnership.
Okay, thanks, Jay. And you're exactly right. We have worked very hard to develop many partnerships to bridge ourselves from NASA to the industry and other government agencies. And we've talked about a few of those today. And so I'll just point out that on the X-48 as well as on the Perseus concept that we discussed, we're working with Boeing Research and Technology, as you mentioned. On the open rotor, which we just saw a clip on, we're working with General Electric Aviation on that particular idea there. Pratt & Whitney, we have also a partnership that we're working with Pratt & Whitney on the next generation UHB engine technology. And I can't forget about the FAA. Carl's here today. We're working really closely with Carl Burleson and the FAA on the CLEAN project and trying to take some of these technologies that have been in the pipeline and accelerate them to commercialization. And then finally, I'd like to mention the Air Force Research Lab. We have a really robust partnership that we're developing there on both the aircraft side as well as the propulsion side to look at future, very, very high efficient future configurations.
Great, Fay. Thanks so much for being with us today. And it is impossible for any of us to describe everything that we're doing to help flying public, but I think your leadership and your project is a good example, outstanding example that what NASA can do to benefit our flying public. Thanks so much.
Thanks, Jay.
Thank you.
Thanks, Beth.
Thank you. Well, next we'll take some questions from the audience, but first let's learn a bit about another one of NASA's Aeronautics Research Centers, the Ames Research Center in Moffett Field, California.
For over 70 years, NASA Ames Research Center has been shaping the science of flight. From wings that enable modern commercial aircraft to spacecraft that return our astronauts safely to Earth, Ames has the world-class expertise and facilities to enable a broad spectrum of aeronautics research. Located in the heart of Silicon Valley, NASA Ames is able to leverage the capabilities of nearby world-renowned companies and universities. For 50 years and counting, our wind tunnels have been used in the development of nearly every U.S. commercial and military aircraft. The ArcJet simulates the heating of atmospheric entry, enabling researchers to develop thermal protection systems for every NASA space transportation and planetary program. Ames flight simulators can model a wide range of commercial, military, and space vehicles. This allows our researchers to develop and test advanced flight deck displays and next-generation intelligent flight control systems. Ames is pushing the envelope with revolutionary concepts for air traffic optimization. Our advanced air traffic modeling and simulation capabilities are critical for developing the next-generation air transportation system. Our supercomputing capability brings state-of-the-art data analysis and high-fidelity data visualization to research partners across the globe. We are investigating sustainable fuel alternatives and developing new aircraft and operational concepts to make air transportation more environmentally responsible. The visionary scientists and researchers at Ames are constantly innovating to enable the next leap forward. Whether we travel in the Earth's atmosphere or through it to another world, NASA Ames Research Center will continue to shape the aircraft and spacecraft of the 21st century.
You're watching The Leading Edge, an aeronautics research discussion program brought to you by NASA. We've been discussing NASA's work in green aviation, work to mitigate environmental impacts of air transportation. Our panelists today are Carl Burleson of the Federal Aviation Administration and NASA's Project Manager for Environmentally Responsible Aviation, Fay Collier. We're going to take your questions now, and I'm going to prime the pump with this question. What are we doing about exploring other solutions besides hybrid wing body configurations? Fay.
Okay, Beth, yeah, that's a good question. NASA's research over the last few years has been focused on hybrid wing body. It is a solution to these environmental concerns, but perhaps not the only solution. And so essentially what we've done is we've gone out recently with a solicitation to the community looking for other ideas in addition to hybrid wing body. So we'll be looking to fund up to 4 research efforts to help us imagine other configurations that could work toward these environmental goals.
Great, thank you. Do we have any questions here in the audience at NASA headquarters?
Hi, yeah.
Hang on, wait for the mic.
Hello. I'm curious, since the hybrid wing body does seem to be the primary design that you're looking at, one of my favorite aspects of flying is the windows. And a lot of these hybrid wings, is it harder to put windows on them? Will they be there? I just kind of wonder the public's acceptance of these new planes. Will it be as fun to fly?
Yeah. So public acceptance, that's a really good question, and you can imagine that I've heard this many, many times. The way I like to answer the question, though, is a year or so ago, I got a chance to go into an A380 mock-up. And you can imagine that an A380 is a fairly large aircraft. And once you get inside the airplane, there are very few people that are actually going to have window seats. It's the same similar story with the hybrid wing body. It is has a large interior. There have been mock-ups of the interiors, and so we've studied those passenger acceptance issues already. So it is a concern, and it's something that we need to put to bed.
Any other questions here at headquarters? 2 in the front.
Yeah, Carl, Fay, both of you mentioned the FAA's CLEAN program, and I wondered if the two of you could comment on FAA's CLEAN program and NASA's Environmentally Responsible Aviation program, and how these two government programs work together or complement each other.
Sure. Again, I think as I was mentioning in my presentation, the way FAA at least is looking at this, and I think we've worked very closely with NASA, is how do we find a structure that we can have both agencies work together, if you would, to create a conveyor belt to get technology out into the fleets quicker. When we were setting up the CLEAN program, I have to tell you that we worked step by step the whole program with NASA. From the time we set out the marketing proposals to helping in the evaluation, because the idea here was how do we make sure that as we develop this process of trying to get more technology out quicker, certifiable, that we have this conveyor belt, as I said earlier, of the concepts and innovation that NASA is beginning at earlier stages that flows naturally into the CLEAN program. So again, certainly that's our vision at FAA, that these would really be closely linked.
Yeah, if I may add something to that, Carl, I do like Carl's description of the conveyor belt. I also like to use technology funnel as we move technologies along in maturation. Getting to the nuts and bolts of coordination, there are 2 projects that within NASA that works closely with the CLEAN. It's the Subsonic Fixed Wing Project and the ERA project. And the 3 teams with Red Jeffries at the FAA running the CLEAN project meet bi-weekly to discuss overlaps, potential partnerships, potential ways to make, first of all, certainly that we're not duplicating effort and that we're lockstep in terms of what we're doing and how we might work better together to mature these technologies and accelerate them to maturation and commercialization, as Carl mentioned.
Go ahead.
I understand sometimes that there are trade-offs between travel speed and efficiency. Will these new aircraft be faster as well as more efficient? And would you ever consider a large fleet of supersonic civil transports?
Oh. Okay, so 2 very interesting questions on both ends of the speed spectrum. So I think in terms of the efficiency, certainly a lot of these aircraft could potentially be faster. There are a number of studies going on right now in looking at next gen of how do we manage the system. Is actually flying faster, flying slower speeds, and how does that, you have the trade-offs not just between fuel burn, but also congestion. So that certainly is being looked at FAA and all the next gen studies. Certainly in the supersonic area, there's a lot of research going on. We're working very closely with NASA in this area. We have actually, as part of our research roadmap at the FAA, we're actually having a series of public meetings where we're trying to collect information in this whole area of community acceptance, because again, I think this is going to be a very important issue, because in supersonic, we actually have right now legislative prohibition from flying over land. So I think that's going to be one of the real challenges of how do we get enough data to actually show that we've made sufficient technological progress that this would actually be acceptable to Americans again.
I'd just like to add one comment to that, and it goes back to the commercial transport side, subsonic. There are, as you mentioned, serious trades to be made between the two technologies that I mentioned, the open rotor and the UHB engine, more conventional UHB engine. Open rotor tends to want to fly a little bit slower. It has its efficiency bucket is at a Mach number which is around 7.5 Mach to 0.8 Mach, and traditional airliners want to fly around 0.8 to 0.85 Mach. So we are looking at those trades, and the technologies, if we want to take full advantage of them, could involve a trade with speed.
Any other?
Yeah, question. Thank you. I wanted to ask, will some of these new aircraft technologies require new development in airport infrastructure, including pilot training and stuff with this new blended wing body style?
Carl, I'll start with that one, and
Yeah.
you can finish up. But yeah. So Carl mentioned earlier infrastructure, and whenever you get into a new configuration design, you have to consider impact on the airport. With the research that we've been doing on hybrid wing body for about 20 years now, we've always looked at designs that fit into what they call the 8-meter box, which is the traditional place where you would park an aircraft when you get to the airport. Egress studies have been done. So there's a lot of work that goes into, once you come up with a configuration that might be viable, to look at all those practical aspects. And we want to make sure that we come up with something that does sort of fit in and doesn't require a whole lot of infrastructure changes, because those are just large hurdles.
I mean, there's always a challenge when you think about the cost of changing infrastructure. But again, this is nothing new. Just when you look at the A380, that clearly is a different sort of animal. That for airports to accept it, they've had to invest in reconfiguration of some of their infrastructure. So there's nothing new about that. It's just that we have to really understand that. But I think to your other point, there's always a human factors element. So clearly, if you have this radically new design plane, certainly we're going to have to make sure from a safety standpoint we understand the human factors element of how this kind of plane operates, not just in the air, but how do you operate in an airport environment? Because certainly one of the big emphasis that FAA has had in recent years is how do we ensure that you don't have problems with runway incursion and taxi incursions in operating in the airport.
And if I could just add one more thing to that, Carl. If you listen carefully to Gary's presentation as well as to the Ames presentation that we showed a minute ago, we do have the capability within NASA, and we have set up piloted simulations for many advanced configurations, including the hybrid wing body. So we do have those simulations and we do bring pilots in, and they can sit in the seat, and they can fly these things on the computer.
I hate to cut you off, but we have one question that we want to get in from Glenn Research Center in Cleveland. Glenn, go ahead with your question. All right, then, we're just going to...
This is Shantaram Pai, Research Center. I have a two-part question. The first one is long-time grounding on runways. Is that can be handled in the arena of air traffic management? And second one is to Dr. Fay Collier. As you recall, at the IGTI conference last week, there was a major topic was discussed in the Rotor craft plenary session, which was one of the best sessions that I have ever attended. The concurrent design concept between engine and aircraft. And third, Dr. Collier, I'm still waiting for a reply for my email. Thank you.
Yeah, I remember our conversation. I do owe you a reply.
They can find you anywhere.
Yeah.
So the question on groundlet, it broke up a little bit.
Could you repeat the first question quickly, please?
the long-time grounding on runways. Long-time grounding on runways. Congress is considering a lot of penalties. Is that to be considered in air traffic management? If we do not pay much attention, all these glorious research ideas may go nowhere.
There's an awful lot of attention being paid to this. It's not just considered. So DOT has put in new regulations, not allowing beyond a 3-hour tarmac sitting, and so basically, and if you miss it, there can potentially be a fine of up to, I think that's $27,000 per passenger. So you can imagine that concentrates the attention of the airlines. Again, I think you're going to see, and we're already starting to see in the system, and how the system is managed, a real concern about making sure that aircraft aren't out that long. So I think that is going to influence the future. And frankly, as more potential regulation on consumer concerns comes out, you will see this reflected in how we manage the air traffic system.
All right, thank you. That'll have to be our last question. We've had a great discussion, but we've run out of time. On behalf of Associate Administrator Jaewon Shin at NASA, thanks to our guests Carl Burleson of the Federal Aviation Administration and Fay Collier, manager of NASA's Environmentally Responsible Aviation Project. You can learn more about NASA's green aviation work and view replays of this program by visiting NASA's website. And there's the URL on your screen. Thank you.